Okay, well, we're going to go ahead and take a look at the derivative. And last time we identified the derivative, but let's just kind of recap for a second where we're at with the derivative. So again, three things that we're talking about with the derivative. One, slope of the tangent line. Two, rate of change. And three, instantaneous velocity. Now, the notation we use with the derivative can be anything like f prime of x or the derivative of y with respect to x. So also, we've kind of talked about, change a little color here. We've also changed or talked about the derivative at a point. So if we were to derive at x equals c, then a formula that we can use for that is the limit as x approaches c of f of x minus f of c all over x minus c. But then we've developed this difference quotient. Difference means subtract, quotient means divide, because we want to be able to find the derivative anywhere. So the difference quotient that we talked about in the last video was the limit as h approaches 0 of f of x plus h minus f of x all over h. And this is going to be our focus. We're really going to kind of work on this right here. So the first question I have for you is, do we always need this formula to find the derivative at a point? And the answer is no, we really don't. What if we had a graph? And what if that graph had a tangent line? Could we find the derivative? Sure, we could. We could count squares for that. So for example, if I made a really quick graph off to the side here, and we drew a quick function and a very quick tangent line. Well, the derivative at this giant point can be found by finding the rise over the run of that tangent line. So we could do that. So the derivative at 1, so we could say the derivative at 1, if this is the x value 1, is the slope of that tangent line. So what if we had a horizontal line? So what if same graph, what if I just drew a horizontal line? And I said, well, what is the derivative at a point on that horizontal line? Well, the derivative would be 0. Because if I put a tangent line to it, well, that tangent line would basically be right on top of it. And the slope of a horizontal line, therefore, is 0. What if I did one more thing? What if on this particular graph, I just drew a line? And what if I said, what's the derivative at any point on that line? Well, if you put a tangent line to the line, it'd be the line itself. So the slope of the tangent line is the same as the linear equation, the graph of the linear equation. So those are some things to kind of consider as we move forward. But let's talk about this difference quotient here. We know it came from the fact that x plus h minus x would give us h on the bottom. Okay. But let's go ahead and kind of take a look at some things. Now, back to the conversation about a line, really quick about the derivative. Think about a vertical line for a second. The slope of a vertical line is undefined. It has no slope. So therefore, a vertical line doesn't have a derivative either. A little side note there. So here's what I want to do. We're going to find the derivative at x equals 2 given f of x equals 3x squared plus 7. And we're going to use this difference quotient right up here. Okay, so let's go ahead and start it off. First thing we're going to do is we're going to identify what we're doing. This is the derivative at 2. So therefore, we're going to have the limit as h approaches 0. And if we follow our formula, because I'm finding the derivative at 2, this 2 is like my x right now. So I'm going to have f of 2 plus h minus f of 2 all over h. Now, the next thing we need to do is we need to substitute. So f of 2 plus h, what that's going to be is I have to put 2 plus h into the function 3x squared plus 7. So I'm going to write 3. Where I see an x, I'm going to write 2 plus h quantity squared plus 7. Now I have to find f of 2. Well, if I put 2 in the function, that would give me, let's see, 3 times 4 is 12. 12 plus 7 is 19. So 19 goes right there. And I don't know why I just erased that. Okay. So we'll put our 1 back in here. Maybe. Okay. And that is all over h. Now we're going to go on down to the next line with this. So let's go ahead and do that. You got that little x there. Okay. So the first thing we're going to do is we are going to keep the 3, and we're going to take 2 plus h times itself. So if we FOIL that out, that's going to give us 4 and 4h and h squared. And then we have a plus 7 minus 19. That's going to give us negative 12. And that is all over h. Now the goal is we have to get rid of the h in the denominator, because right now I can't substitute 0. So let's keep going. Let's distribute the 3 through next. And I need to put my minus 12 on the end. So now what I can do is I can take those 12s away. So I'm left with 12h plus 3h squared all over h. Now, the way I can think about this is I need to take an h out of everything in the numerator, denominator, because I have addition up there. So what I'm really doing is if I factor out an h out of the numerator, I'm left with 12 plus 3h over h. And now because I have this factor of h in the numerator, those h's, h divided by h is 1. So therefore, I'm left with 12 plus h. So now I can go ahead and put 0 in. And when I put 0 in, I need to back up just for a second here, don't I? Because I need a 3 in there. So this should be 12 plus 3. Sorry about that. So this will be 12 plus 3 times 0, which is 12. Therefore, the derivative of this function, which we said was f of x equals 3x squared plus 7, is equal to 12. Now, that's fairly tedious to find the derivative at just one x value, but that is how it can be done. So let's buzz back over to the study guide for a moment. And last time we kind of worked through some of this. We were able to figure out that this formula up top here was x squared minus 2x plus 3, and the value of x was 4. What I'd like you to do is I'd like you to take a moment and I'd like you to do part C. Now, what we're really finding on part C is we are finding f prime of 4. So go ahead and pause the video and see if you can simplify the difference quotient that exists up above. And I'll be back with you momentarily and I'll work through it. Okay, first of all, what would I do? Well, what I would do first of all is I would go ahead and FOIL out 4 plus h times itself. So that's 16 plus 8h plus h squared. And then distribute the -2 through. So that's -8 minus 2h, and 3 minus 11 is -8 right there, all over h. And again, this is a limit process, so I do need to put the limit as h approaches 0 in there as well. So now I need to clean up the numerator. Well, 16 minus 8 all goes away. I'm left with h squared, and 8h minus 2h is positive 6h all over h. Now, I could factor out the h right away right here into each term, or I could go ahead and show it just like this. And what that's going to leave me with is, because those h's go away, I'm left with h plus 6. I can there and put in 0, and I get a final answer of 6. Therefore, f prime of 4 for this particular function is indeed 6. Now, let's jump down a little bit to part B. I'd like you, again, pause the video, write a formula using the difference quotient that would specifically find the derivative of g of x equals 10 over x at x equals -5. Try that. Okay, so what would we write for that? Well, we would write that g prime of -5 equals the limit as h approaches 0. And we would write 10. And where I see an x, I would write -5 plus h in place of that, because our formula says I need f of x plus h first of all. So that means I'm going to put -5 plus h every time I see an x. And then from there, I need f of x. And so I'm going to put -5 into the function g, and that will give me -2. And that is all over h. And the last thing to just kind of talk about here is it possible not to have a derivative? Well, the answer is yes. So if we take a look at the study guide problem, here's h of x equals 2 over the square root of x. So you can't have change on something that doesn't exist. So we have to look at h of x right here and go, okay, are there any values of x that don't work? Well, yeah, there are. In fact, we can't use 0 for x, and we can't take the square root of a negative number. So therefore, we could state that h prime of x does not exist when x is negative or 0. Thus, we can write it when x is less than or equal to 0. Okay, so let's go ahead and move on here. Because again, like I said, this derivative process, very tedious if you had to do what we did before in this green section for every single point. So there's got to be a little bit better way. And we're gonna see a lot of patterns that happen in math along the way too. So let's just kind of keep diving into that. Now again, we are still using the difference quotient. So difference quotient, remember, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And we're going to find what's known as the derivative in general, okay? So our last example, and then we're going to go ahead and take a look at this. So let's go ahead and do this. Let's state our item. Find the derivative in general given f of x equals 5 square root of x. Then determine f prime of 4 and f prime of negative 1. Okay. All right, so let's go ahead and set this up. So to set this up, we're going to find the derivative, and in general means whatever x value, we're going to develop a formula no matter what the x value is. So the derivative will be equal to the limit as h approaches 0. All right, and we're not concerned about what x is right now. Even though we have some x's down here, I really don't want to do this problem twice. Or for any particular number, I want to do it once. I want to find a derivative in general and then plug in any x values that I need the derivative of. So here we go. The first thing I've got to do is, I'll kind of color code this a little bit, is this f of x plus h right up here. I need to put x plus h into this function. So that would read 5 times the square root of x plus h. And then next, my formula says to subtract. And then I'm going to subtract f of x. We'll make that green. And f of x is 5 square root of x. And that is all over h. Now again, our goal is we have to get rid of that h. We have to make it cross out with something in the numerator. So we need to look at this and kind of make a decision about what we want to do. So we're dealing with square roots here, so we probably are going to need to multiply and rationalize. So to make life a little easier, let's go ahead and multiply or pull out a 5 and get to there. Now, I guess before I write this equal sign, I'm going to multiply by the square root of x plus h plus the square root of x over itself. So basically, I'm going to multiply by 1. And we'll jump down. So I'm going to keep my 5. And the square root of x plus h minus the square root of x times its conjugate then, and this will have to be in parentheses, that would be x plus h, because if I distribute these roots here, that'll give me just x plus h, and then the square root of x times itself is also x, so that's going to be a minus x. That is all over h times the square root of x plus h plus the square root of x. Now, that'll clean up a little bit. The x's in the numerator disappear. X minus x is 0. So this becomes 5h over h times the square root of x plus h plus the square root of x. And because I'm dealing with multiplication, these h's, h divided by h becomes 1. So therefore, I have 5 and the square root of x plus h plus the square root of x. And now I can go and put 0 in for h. So that's going to leave me with 5 over the square root of x plus the square root of x. And that means I have 2 of them. And what I've just found is I have found the derivative in general. It's exactly what I wanted right there. So now what I can do with this difference quotient that I just used, I have this formula for the derivative. So what I'm allowed to do then is I'm able to answer the two questions, namely find f prime of 4. So to do that, I can just put 4 in for x. That gives me 5 over 2 times 2, or 5 over 4. Done with that one. And now I'm going to go ahead and find f prime of -1. Well, that should have been a light bulb moment, because at -1, I can't even put -1 into the function. It would be imaginary, not a real answer. Therefore, my derivative is undefined. It doesn't work in the derivative either. So I can't have a derivative at a point if it doesn't necessarily exist. So I have a final question before I have you practice something like this. What about 0? What about the derivative at 0? Because if you look at the function up above here, you can put 0 into the square root. The answer would be 0. But look, if you try to put 0 into this derivative, it's going to be undefined. So the derivative, okay, so the derivative at 0 is undefined. Now, the question is why? Why is that happening? Well, let's kind of explore the why. It kind of happens with the graph. So this is the graph. It's kind of what the graph of 5 square root of x looks like. It starts at 0. So now we're dealing with a limit process that's two-sided. So yes, there could be a derivative from this side, but there's not a second side. That's a theory. The second thing is we're starting the graph at 0. How can the graph be changing if it's just getting started? Second theory. So we say the function is not differentiable at 0. And more on this to come in the course. All right, we're going to go back to your study guide here. And on your study guide, I'd like you to do problem D here. Problem D says use the limit definition of the derivative to find h prime of x in general given h of x equals 2 over the square root of x. Then we're going to find the three things at the bottom. So again, pause the video. It is so important that you have a chance to practice this, to make sure that you are understanding things, and to correct any misconceptions that you might have. So try it. It's a fraction and a square root all mixed together. So see what you do with that. Be back in a moment. Okay, so I'm getting this set up for us. This is how we need to go ahead and get it started. We've put in x plus h every time we see an x. So here's our f of x plus h first, minus f of x all over h. Okay, so we're going to need common denominators. So I'm going to need to multiply this by the square root of x over itself. And we need a radical of x plus h over here. All right, so that's going to give us 2 times the square root of x minus 2 times the square root of x plus h all over the square root of x times the square root of x plus h all over h. And you're going, that's a lot of radicals in the same problem. It is. You're welcome. So let's go ahead and take the 2 out like we did in our last example. And we cannot necessarily combine those denominators at the moment. Let's just leave those be. Now, I'm going to multiply again by the square root of x plus the square root of x plus h, top and bottom. And then we're going to go ahead and jump down to the next line here. So I'm going to have a 2. And if I multiply the square root of x times itself, that's going to give us x minus, and now multiplying the square root of x plus h times itself, that's going to give us, and I'm going to need parentheses for that, x plus h. And that is now all over the square root of x times the square root of x plus h, all over the square root of x plus the square root of x plus h. And don't forget the h in the denominator. My gosh, we've got to get rid of that h on the bottom. Right now, you just feel like erasing it, but no, we can't do that. So let's keep going. Inside of these parentheses, right up here, a little dark star there for it, okay? We have got to go ahead and simplify those set of parentheses, okay? So when we do that, that's going to give us x, and we're going to run this negative sign through, so that'd be x minus x. Those are gone. And I have a negative h. So what I would have is I would have 2 times a negative h. So, hey, that's just going to give us negative 2h. Now, simultaneously, let's go ahead and move this h up. So we can multiply by the reciprocal of h and string this out a little farther. So that h, remember the denominators always kind of join forces eventually. Gets us to there. I can then remove those h's because everything is multiplied. I have negative 2 over the square root of x, the square root of x plus h, the square root of x plus the square root of x plus h. Yay. And now I can put 0 in. So we're getting there. Let's jump down again. So that negative 2 is still going to hang out. I'm going to have a square root of x. Now this one right here, if I put 0 in, is also going to be a square root of x times the square root of x plus, this will be a square root of x as well. So to clean this up, the radical x times the radical x is just x. But inside I have to add, so that's 2 of those radicals of x's. So that's what I've got so far. Those 2's will go away. And I'm left with negative 1 over x square root of x, which, if you like exponents, that's negative 1 over x to the 3/2. And I'll leave that with positive exponents. So our h prime of x is either one of these. So to find h prime of 9, I think I'm going to use this first version here. So that would be negative 1 over 9 times the square root of 9. That gets us negative 1 over 27. Okay. Again, I don't want to go through this whole process with 9. And then I don't want to do the whole process with 2. No offense. But again, I think we can do it much quicker like this. So this will be negative 1. This will be 2 times the square root of 2, which, hey, that's a-okay like that. Or if that makes you nervous because you're going, it's got a radical in the bottom, you can simplify it. And finally, if we try to put negative 1 in, we'll get negative 1 over negative 1 times the square root of negative 1. Well, that's imaginary. It's not a real answer. Undefined. Okay. Well, that is a look at the difference quotient. Next time, we're going to talk about how you can apply this in some other different ways with some different kinds of lines. So I look forward to sharing that with you next time.